Hello, I am Dr. Atulya Patil. Welcome to my YouTube channel DAP. In this video, we'll study the flow measurement devices, and the first is the notch and the weir. So let's say you want to measure the rate of flow or discharge through a canal or through a stream or through a river. Then in that case, the notch and weir is used. So basically, the notch and weir is what? It is a device which is used to measure the rate of flow. Now, there is a difference between the notch and the weir. Notch is what? Of smaller size, hence it is used for smaller discharge. Whereas the weir is of larger size, hence they are used for the higher discharges. Basically, the notch is used for the laboratory purpose. When you want to find out the discharge through a rectangular flume, then we use the notch. Now, what is notch? The notch is an opening. It is an opening provided in a tank or channel such that the depth of the water or liquid in the tank or channel is below the top edge of the notch. That can be explained like this. For example, if this is your rectangular flume and the liquid is flowing in this direction. Now you want to measure the rate of flow for this particular canal or channel. So here we insert one metallic plate, which is nothing but a notch. And so the depth of the water in the channel or tank is below the top edge of the notch. In a view, sectional view, you will find that if this is the bed of canal or say flume, then this will be a section of a notch, and now the liquid is flowing above this. So the top edge of the notch, this one is the top edge. This is called as crest. Top edge of the notch is called as the crest, and water will flow above the crest. So the flowing sheet of water, this one, the flowing sheet of water will be known as nappy. And this will be your height of the notch. Height of the notch. Now we'll classify these notches. That is the classification of the notches. The first classification, that is the classification of notches. First, depending on the shape, you get rectangular notch. That is, the notch is like this, rectangular one. Then you get triangular notch. The shape of the notch will be like this. Then you get the trapezoidal notch. Now the shape of the notch will be trapezoidal, and step notch. That is, you get the steps. So based on the shape of the notch, we get rectangular notch, then triangular notch, trapezoidal notch, and the step notch. Now this classification was based on the shape of the notch. Now based on the effect of side on nappy. That is the effect of the side on the nappy. So your notch may be like this. This notch is called as suppressed notch. When the width of the flume or canal is equal to the width of the notch, then it is called as suppressed. And sometimes you get the notch like this. So this will be your length of the notch in this case, whereas this will be length of, let's say, canal. Now based on the effect of side on the nappy, you get one as notch without end contraction, this one there is no end contraction, and second will be notch with end contraction. So this will be a notch with end contraction. Now we'll see what happens in the case of a notch in which the end contraction is considered. For example, this was our rectangular canal, and now in this case the notch is fixed, but the length of the effective width of the notch was like this. If you take a section of this, so what happens when the water flows, you are using from the top view, so water enters like this, and then this flowing water is contracted, so you get this as the reduce. So this much part or this much length is reduced because of the end contraction, and if this is L, that is the length or width of the notch, then this part, this one as well as this one will be 0.1 H. 0.1 H. H is what? Head is the water, depth of water above the crease of the notch. We call it as a head. So your effective length now, instead of L, it will be L minus 0.2 H. So where here it will be L, now this particular will be reduced to L minus 0.2 H when we consider the effect of the end contraction. So based on the shape, you get again rectangular, triangular, trapezoidal and straight, and based on the effect of the sides on the nappy, you get notch without end contraction and notch with end contraction. Then we'll come back to the next flow measuring device, that is weir. It is also used to measure the rate of flow, but now weir is of larger size, so hence it is used to measure the higher discharges. For example, if you want to find out the rate of flow or discharge through a river, so then wall is constructed made of masonry or concrete, so that is called as the weir. Now as far as the classification of weir is considered, first, based on the shape, again you get the same here, that is rectangular weir, then triangular weir and the trapezoidal weir, that is rectangular, triangular and trapezoidal weir. Second, again the same, that is the based on the effects of the side, again you get weir without end contraction as that of notch, and weir with end contraction. And third, you get the based on thickness, you get sharp crested weir, then second narrow crested, then broad crested, and oggy shape. Sharp crested means the edge is a little bit sharper. Now what is the difference between the narrow crested and the broad crested? Imagine that there is a weir and water is flowing above this. So if this is the head of water on the upstream side of the weir, this side is known as upstream side, and once it passes, this will be your downstream side. So if this is the head of water, above the crease, this top edge of the weir is creased and its length is, let's say, L. Now if twice L is greater than H, if twice the length of the weir is greater than H, then it is referred as broad crested. And if twice L is less than H, it is called as narrow crested. And last is the augie shape. In augie shape, the shape of the weir is just like this. It is made of cement concrete, so water will flow like this on this. So this is known as the augie shape weir. So in this video we have seen the theoretical part of the notches and weir. The difference between notch and weir is that notch is of smaller size, hence it is used for the smaller discharges. Weir is of larger size, so hence it is used for the larger discharges. Basically, notch is used on the laboratory for the experimental purpose, whereas weir is used to find out the discharge through the river, canals or the streams. The edges of the notch is sharp and thin, whereas the edges of the weir are wide one. And the notch is made of metallic plate, whereas the weir is made of masonry or concrete structure. So this was the theoretical part of the notches and weir. In my next videos we will solve the numericals based on the rectangular notch. Thank you. I hope it was easy learning for you. Please like the videos, share the videos and subscribe to my YouTube channel DAP. For further videos, please do not forget to press bell icon. See you soon.